We've just developed a smart contract for a decentralized auction, something like eBay. Let's test our smart contract in detail to see how it works. So just for our tests, I'll make some changes. I'll use the JavaScript virtual machine, the in-memory blockchain, and every transaction will be its own block. So it's very complicated to have 40,320 blocks because in this case I need this number of transactions. So here I'll write a very small value like 3, for example. The auction ends in 3 blocks. So after 3 transactions, I'll have 3 bidders, and after that the auction ended. And also here I want to make a change. This value is in way, and for our tests to be easily for us to understand, I'll use Ether. So I want to have a bid increment of 1 Ether. Using the online converter, I can see that 1 Ether is this very big value. So I'll copy this value from here and paste it here. The contract logic is the same. And now, using the JavaScript virtual machine and the first account from here, I deploy the contract. The contract has been deployed. And using the second account, I'll send, let's say, 3 Ether to my contract by calling the placeBid function. The third account sends 5 Ether by calling the same function named placeBid. And the fourth account will send, let's say, 10 Ether by calling the placeBid function. So we have 3 bidders, the second, the third, and the fourth account that sent Ether to my auction. So they wanted to buy the service or the product. Okay. Let's see what values do the state variable have. So the auction state is running 1, running 0, 1, 2, and 3. The highest bidder must be the last bidder, the address that starts with 58. Okay, this address sent 10 Ether. And the highest binding bid is only 6 Ether. Why? Because the application automatically bids the increment, so 1 Ether, over the previous highest binding bid, that was 5. Yeah, the second bidder sent 5 plus 1, the increment is 6. So this is the selling price. Everything works as expected. Then now, as the owner, so using the first account, I want to cancel the auction. The auction has been cancelled. We can see this if we press here. So auction state is 3. This is cancelled. Okay, let's take a look over the finalize bid function. So this function from here. The auction state equals state.cancelled. What will happen? What is the program flow? When the auction state is cancelled, then everybody requests and transfers back the amount they sent. So everybody receives his own money. Okay, let's try this. So the second account sent 3 Ether. So using the second account from here, I'll finalize the auction. We can see that the second account received his money, his 3 Ether. The third account sent 5 Ether. So using the third account, I'll finalize the auction. And we can see he received his money. And the last bidder that sent 10 Ether, okay, we can see, if we want to see how much Ether this bidder sent, I can copy his address, paste it here, okay, and we can see the value. Here we have 10 Ether. Okay, this account wants his money back because the auction has been cancelled. So we press here on finalize auction. And the account received his money. Okay, this interface is very simple, but we could create a nice interface using a JavaScript framework and HTML and CSS, and using the Web3 library, our application, our front-end application will connect to the Ethereum blockchain and will call all these functions. So instead of this button here, we can imagine a very nice button with a nice design. But the logic is the same, nothing changes. Okay, so finalize auction works when auction is cancelled. Let's try another test. This time the auction ends after a specific number of blocks, in our case after 3 blocks. And we want to see how the owner gets his money, so gets the highest binding bid. So one more time, using the first account from here, I'll deploy the contract. The contract has been deployed. The second account sends 3 Ether by calling the placeBid function. The third account sends 5 Ether. And one more account, let's say the last account, sends, it doesn't matter how much he sends, because the auction price will be the previous highest binding bid plus the increment. So if he sends 90 Ether, it doesn't mean it pays 90 Ether. How much does he pay? He pays this price. So 6 Ether. 5, the previous highest bid, plus the increment. So we had 3 transactions, so our auction ended. I changed the account from here, so this is the owner. That finalizes the auction that ended. Look, the account received the auction price, those 6 Ether. The auction price, or the highest binding bid, has been automatically transferred to the owner. And now all other bidders can request and must request their money. So if this bidder from here, the last one, the winner, calls the finalize auction function, he will receive the difference. Yeah, the difference of the bidding price and the winning price. So he bid 90 Ether, but the auction price was 6. So he received the difference. This one from here also received the difference, received his money, and also the second user finalizes the auction and receives his money. So everybody received back his money, the highest bidder received the difference, and the owner received the auction price, or the highest binding bid. Everything works as expected, and we are proud we have a decentralized, unstoppable auction application. Of course, this application needs a nice front end with a nice design, but the backend logic is what we've programmed here.